minus 6x. So the given is y equal to x squared minus 6x plus 8, where y, okay, y is changing at the rate of negative 1 unit per second. Find the rate of change. Wait, let me just accept this people. Find the rate of change of x when x is equal to 4. Okay, so to solve problems like this, we just need to analyze the things that we have. Okay, so from here, okay, for those who are visual learners, you can actually just graph this. We have here a parabola, so it's something like this. Okay, any parabola. Okay, but then we have here a rate which is now negative 1 unit per second. So that's a negative gradient. So I'm imagining that it will be something like this. Okay, something like this. Okay, so this is now our line or our tangent, and we have a rate of change in either x or y. That means now that we have our delta y and we have our delta x over here. That's now our delta x. This is our delta y. So as x is moving towards this area, the y is also moving towards that direction. Okay, so delta x and delta y. So the faster that y moves up or down, in this case, the x will also move faster towards the right. Okay, and it is now all. Okay, so how do we solve that? The next thing that you need to do is to identify the parts that you have here. First of all, what is this? Rate of change of negative 1. This belongs to what? Delta x or delta y?
dt. Delta
Okay,
y.
so that will now give us dy. It's a change of y, and rate is with respect to time. So dt. So dy dt is negative 1. Done. We are looking for, okay, so find the rate of change of x. So we are looking for dx per dt. Okay, so that's the thing. The question is, how are we going to connect these two? How are we going to connect these two together? We can use the original function given to us, which is now the parabola. We will now have here y equal to x squared minus 6x plus 8. But we need to find the derivative, okay, of this. You get your dx of this. You derive it with respect to x. So dy dx is what? Dy dx is? Come on, derivative of this, anyone?
2x minus 6.
Okay, 2x minus 6. So how are we now going to connect these two together? Okay, the way to do that is you copy that dy per dx, And then if we multiply this one with dx on top, which one? Dx on top, that's here. Dx per dt, okay? What will happen? This one will cancel, correct? Ini, coret-coret. What's left is dy dt. dy dt. Okay, can you follow what happened there?
Yes, teacher.
Yes.
Okay, so all you need to do now is to substitute the values that you have. We have this value, we have this, and you can now find this. So we are looking, what we have is dy dt, so that means that's negative 1 equal to dy dx 2x minus 6, and this is now multiplied to dx per dt. So all you need to do is to divide both sides by 2x minus 6. Final answer, dx per dt is now equal to negative 1 per 2x minus 6. Okay, however, this is not the final answer. When or what is the rate of change when x is equal to 4? Okay, so we need to evaluate this one at x equal to 4. So answer,
It's negative half units per second.
negative 1/2 units per second, or 0.5 units per second. Okay, so questions? Questions on how to do this?
None at the moment.
None at the moment. Okay, so now that we understood the algebraic concept of it, okay, we have here just a graph, we have a change in y, change in x, and we were able to get dx dt. Okay, so we understand it on paper, but how can we relate this in real world situations? Okay, in real world situations, let's do this. Can I erase? Can I erase? Yes or no?
Okay, teacher.
Wait. Okay. In 3, 2, 1. Okay, delete. Okay, so let's have a problem. So a spherical balloon being inflated Okay, so you can imagine a balloon that is now being inflated with air, so it's becoming bigger. When that balloon is going to become bigger, there are a lot of changes that are happening to it. Okay, so a spherical balloon being inflated is, oh wait, the radius. Okay, I forgot to place that one. So the radius of the radius of a spherical balloon being inflated is increasing, obviously, is increasing at a rate of 0.2 of 0.2 centimeters per second. Okay. Next, find the rate of increase in the volume of air, okay, in the balloon when the radius is 6 centimeters. Okay, so you can imagine a balloon being inflated, right? So as the balloon is going to become bigger, obviously, the radius is going to be bigger or longer. And it's not only the radius that is now going to become longer, okay? As air is being filled in to the balloon, the volume of air it contains is also becoming bigger. So we have two different components here. We have here volume, okay, volume and radius. Okay, so the question goes, how fast is now the volume increasing when the radius is 6? So volume is a different unit compared to a radius, okay? Right? So we need to find a way to relate volume with radius so that we can do our calculations. Okay, so first of all, what are the information given to us here? The radius is being inflated, has a rate of 0.2 centimeters per second. So how are we going to notate this one? Anyone? Rate of change for radius. So we can label it as
DYDT, DRDT.
why you want. Okay, dr radius per unit of time. So dt. So dr dt is 0.2. Okay, good. Next, rate of increase of volume. Rate of increase of volume of air in the balloon. So what is that?
dV over
dv
dt.
dt.
Yeah, that will now be dV per dt. And this is now unknown. However, we do not have a function to connect these two. So what will that function be? Okay, we need to find a function to connect these two together. So what function can we use that uses radius and volume? Anyone?
drdv.
DODV.
Yeah, we need to get that. We need to get the V, not the RDT. We need to get the VDT.
dV
What
per
will be the
dr.
function? Yeah, sorry. We need to get dV per dr. But what function are we going to differentiate?
Volume of
Volume of a circle. Good suggestion. What circle?
I mean
Not a circle.
sphere,
That's the
sphere.
volume of circle.
Sphere.
Okay, so volume of a sphere. So what's the volume of the sphere? What formula is that? Volume is equal to
4 per 3 pi r cube.
pi r cube. So that's a function that we need to find. Okay, so that is the volume. Yeah, that's a volume formula, right? So there, it uses V for the volume and it is calculated using radius r. So if we get the derivative of this, d per unit r, dr, what will we get? Anyone? 4/3 and pi are treated as
So
constant.
3r cube, 3r squared.
Again, sorry,
3
Dante,
3
what was that?
r squared.
3r squared. But this is going to be constant. So 4/3 pi times 3r squared. Okay, next, this one, Choret. So what we have is dv per dr is equal to 4 pi r squared. Clear? So
Clear,
with
teacher,
this,
teacher.
we can now relate the three together, starting with dv dr. So if I will write dv per dr over here, and I will multiply it with dr on top. Okay, dr on top, which is now this one, dr per dt. It will cancel, giving us what? dv per dt. Okay, so it's the same idea as a while ago. Just substitute the information that we have. We are looking for this, so that will remain as the same. It's equal to dv dr. That's 4 pi r squared multiplied to, let's use parentheses, multiplied to dr dt,
0.2.
0.2.
0.2. So dv per dt is what? 0.8 pi r squared. And we need to evaluate this one when the radius is 6. So when, wait, yeah, when the radius is 6, r equal to 6. So what do we get?
28.85.
In decimal, please, easier to understand.
Okay. 90.47, is it? 48, I mean.
90.48.
I got 90.48. Yeah.
Yeah, 90.48. And do not forget your units, because this one is now using two different units. So what is this? Volume
Centimeter
over
cube
time.
over second.
Correct. Okay. There. So you can just imagine, okay, it is a sphere. Yeah? It's a balloon, but then it starts to become bigger. Like it expands in spherical motion. Okay. So aside from being a balloon, more what's this? A different application of this is during an explosion. With a small point, but then when it explodes, the wave, the shock wave that is now going to be forming is going to become bigger and bigger, right? That's a shock wave. That's the same instance as this. So the radius of the shock wave is going to be moving bigger and bigger, and the volume covered around the shock wave is now going to be uh, a lot of heat and energy there. So we call that one as the blast area or the blast region. Okay, so this is just one application of these types of calculation. Okay, clear? So extreme, maybe extreme application. If you be dealing with explosion and the waves in the future, this one will become in coming in handy, especially in the fields of physics. Okay, clear?
Clear, teacher.
Questions with this? Questions on this? Yeah.
Yeah, I
No?
don't think that's right. No.
Okay. So, bring out your textbooks. Open your textbooks to page 38. Okay, textbooks, page 38. At the bottom of the page, You will see there, try it exercise number 9. Okay, try to do that. The radius of a circular water ripple is increasing at a constant rate of 2 centimeters per second. Find the rate at which the area of the water ripple is increasing when the radius is, when the radius is 10 centimeters. Okay, what's a water ripple?
A fountain. Not sure.
Like a fountain? It's not a fountain. Okay, you gave the same, explanation as Richard. Okay, it's not a fountain or it's not a sprinkler. A ripple, okay, is, have you ever thrown a stone in water?
Yes.
Oh, yes. Yes.
What happens? It hits the water and then suddenly there will be rings. And these rings are going to be moving, right?
Ripples.
Yeah, it becomes bigger. So this is a ripple, okay? That's what you call a water ripple, okay? So what's the information given to us here? Okay, the information is the
DRDT.
radius is becoming big, wider, right? The radius is increasing. So we have what you call your dr dt, which is now what? 2 centimeters per second.
2 centimeters per second.
Yeah, okay. So 2 cm per s. Then, what are we looking for? We're looking for how
DVD.
much is the area?
DADT.
Area. It's dA per
Yeah, DA.
dt. Okay. When the radius is at
10 centimeters.
10 centimeters. Meaning we need to relate that area, okay, with the radius r. Okay. Can you get a diagram? I hope that you can understand the diagram. So we are looking for dAdt and we have drdt, but what function relates the two?
DADR.
We need to find dAdr. dAdr, this one will come from where?
D over dr of
Find
the
dDr
area.
of area. Okay, the area formula is what?
Pi r squared.
Okay, so area is equal to pi r squared of the circle. And we need to connect it with this. So we need to get dr of this one, which is now
2pr.
2 pi r.
2 pi r. Okay, take out. This is now dA dr. Yes, it looks like the Koliling formula, 2 pi r. But in our case, we are not concerned with the Koliling. We are concerned with the change. Okay, clear? Okay,
Clear.
but this is a way to get the Koliling if you know the area. Okay, we use this in geometry. Okay, but dAdr is equal to 2 pi r, right? So our working formula this time is going to be dA per dr kali what? dr per
The rdT.
dt will give us dA
DADT.
dt. Okay, so substitute.
2 pi r times 2.
So dA, we are looking for dA dt. So dA per dt is equal to 2 pi radius kali 2. So dA dt is equal to 4 pi radius when r is what?
10.
When r is 10. Okay. What will be our answer here? 40 pi. Yeah, that's 40 pi. Or in decimal,
125.66.
125.66.
units. Do not forget your units.
Centimeter squared per second.
Centimeter squared per
second.
second. Okay. So there. That is now your second problem. Questions?
Teacher.
None. Okay.
Teacher.
Yes. Kaya?
What value do we use for pi?
The calculator value. The
Okay.
complete
Thank
one.
you, teacher.
So, okay. Any other questions? Okay, the thing here is by next week, I am planning to giving you your test already. And the test covers everything that we have learned so far from the whole of January, okay, until here. And that will be the test is February 4. That will be Thursday next week. Any other subjects who schedule the test during the day?
Yeah, Bina and Physica.
Pina and
Physica.
Physica. Oh, we have physical already. Yeah. How about Tuesday? Earlier?
Yeah, there's no subject for Tuesday.
But I'm planning to give a review on Tuesday.
Yeah, that's why.
Okay, I can give you the Tuesday next week. What's that? What day is that? Tuesday next week. 9. No. 2. Wait. When's our holiday? That's 2. Cannot already. Is it fine if I will give it on Tuesday without having review anymore?
I don't know about the others, but personally, I
What do you think?
for me, Thursday. But I don't know about others.
Because you only have two choices. We take it on Tuesday, or we will have another test on. You will have another test on Thursday. Votation. Raise hands to take the test on Tuesday. Put a thumbs up. No one wants it Tuesday. We will have additional test on Thursday. Thumbs up. Additional test. Dua. How about the rest? 4? How about the rest? I'll repeat the question. Have the test on Tuesday, this following meeting. Following meeting, test already. 3 people, 4 people. Still waiting. Anyone else? 5, 6. This Tuesday, 7. Okay. 8. Ada lagi? 10. Okay, I counted 10. On Thursday, together with Dina and Pisika.
Teacher, I wrong vote, teacher. I thought teacher just said Thursday.
Charson. So 9, other one. Okay, let's count again. Who wants it on Thursday together with Dina and Pisika? 1, 2, 3, 4, 5, 6, 7, 8. I also counted 9, 10. Okay, because of Jaya, got 10, 11, Teresa. So, majority wants it together with Dina and Pisika on Thursday. Okay, so majority wins, yeah? So if there's another subject who is going to schedule on that day, tell them, sorry, overbook, already free. Yeah?
Okay, teacher.
So your test is going to be February 4. And that's the same schedule for the other classes. So it's okay. Okay, that's it. Finally, I also, yeah, may I ask everyone to please turn on their videos? Okay, finally, final announcements. After the exam, okay, after the test, I am planning on offering robotics online. Okay, robotics classes online. It's a free service. Okay, it has no bearing with your grades. Okay, I just want to teach robotics because it's been a year since the last time that I tinkered with the robotics and programming. And if I am not using programming, the logic gets forgotten. Okay, so you become what, like back to zero again, and you forget your skills. And I do not want to lose, you know, these things. And it's also an opportunity for those students who wants to continue robotics and who doesn't want and who wants to start robotics again. Okay, so I am just counting willing or students who wants to do online robotics. I will be offering it around 3 o'clock until 3:40. Certain schedules. So after classes, we can still do online, and then after that, done. Okay. So at this point, at this moment, raise your hand or put a thumbs up those who are willing or who wants to join so that I can count. In the other class, they have 2.
Teacher, what dates?
What day, teacher?
I do not know. We will set after, but the time is 3 to 4. Or 3,
I'm not
no,
sure if
sorry.
I'm available on Sunday, teacher, but I
No,
guess
it's week after class.
yeah,
weekday.
that's why.
After class,
What?
I'm not available.
Yeah, sometimes after
Oh,
class on
Some days.
like
yeah.
what days are you available?
Except Tuesday and Fridays.
Except Tuesday and Friday. So we can work around it. Monday, Wednesday, Friday, maybe. So let me count again. How many are interested to continue or joining?
I'm
1, 2.
interested, but if my schedule can fit.
Okay, so we can work on that. At least I have 7, around 7 already. Okay, no, I think it is possible but this one is after. So that's it. So thank you. We will have another meeting by next week. We will use that for review. Okay. So that's it for today. Goodbye.